Okay, Objective 3 for Unit 3 in Honors Math 3, seems to be a theme there of threes. We're learning how to write the equation for a polynomial function if we give you some information. Now, just briefly, let me remind you that the first couple of objectives we were learning if we're given the equation, how to deal with it. And we also learned that factored form is a very nice form. So let's say I had a polynomial function in factored form. Y equals 2x plus 7 times x minus 1 quantity squared times x plus 5. And so the zeros of the function, or the roots of the function, because they are synonymous, we would be plugging in 0 for the y and solving for the x's. And so since it's in factored form, I can set each factor equal to 0. So I get negative 7 halves. I get 1, of course, x minus 1 quantity squared, so the multiplicity would be 2 because it happens twice there. And I also get negative 5. So these are the roots, the zeros of that polynomial function. Well, we're going to be kind of going the reverse process here. And so it's kind of nice to remind ourselves of that. So now this time, write the equation for a cubic polynomial function. So third degree polynomial, which means that we will have 3 roots, 3 zeros. And given the zeros, negative 4, negative 1, and 3/5. Okay, so equation needs to be an equation. So y equals, or f of x equals. Now, there's always a multiplier. And so just go ahead and get used to writing an a out in front. There's always a multiplier. Sometimes the a is 1. Many times it's some other number, but just go ahead and write that out there. Now, if the 0 is negative 4, what factor did it come from? Didn't it come from x plus 4? And if the root or the 0 is negative 1, so x plus 1, and if the root is 3/5, so x minus 3/5. However, that's really not good math grammar right there. So here's how we can do that. We don't want to have fractions unless we need to have fractions. So what we can do is we can say x equals 3/5, and then let's just kind of go backwards. So if I get rid of the fractions, if I multiply by 5, I get 5x equals 3. And then if I bring the 3 over, I get 5x minus 3. And so there's the nice way to put it in our equation. 5x minus 3. Okay, now, did they give us any other information? No, they didn't give us any other information. So we literally do not know whether this function is starting from low and ending high, or if it's high to low. It's possible either way. And so because we don't know any more information, and by the way, notice the choice of words. It says write the equation for a cubic polynomial. So really, they're not giving us enough information to actually figure out what the a is. We don't even know if the a is positive or negative. Now, by the way, just in case the wording in some of the problems says a function, don't think that they might have given you some extra information for the a value. So pay attention to the information that's given, not just the English there, because sometimes as math teachers we don't always get the grammar completely correct. Anyway, write the equation for the cubic polynomial function with roots. Remember, it could be roots, zeros. Now these are the exact same, and I'm doing them exactly the same just so we can see the difference. Here they were zeros, here they are roots, but it means the same thing. So really, we've got y equals a times x plus 4 times x plus 1 times 5x minus 3. But this time they did give us some extra information. They said the y-intercept is 60. Now, what is y-intercept as an ordered pair? Well, as an ordered pair, wouldn't it be 0, 60? There's an x, there's a y. A point on a graph has to work in the equation every single time. A point that is on the graph has to work in the equation every single time. So let's plug it in. 60 equals a times 0 plus 4, 0 plus 1, 5 times 0 minus 3. Now, I don't expect you to write the zeros like this in the future, because in the future I would expect that you would probably just do a times 4 times 1 times negative 3. And so anyway, we can solve for a. A is 60 over negative 12. Okay, now no decimals. Don't be giving me decimals for the a values. You give me reduced fractions, but sometimes they reduce to a whole number. So 60 divided by 12, it is negative, and that is negative 5, isn't it? So in place of the a, we're going to put a negative 5, and we will be done. By the way, do we have to multiply these out? No, and in fact, we don't expect you to multiply them out typically. Now, if called upon, should we be able to multiply them out accurately? Yes, but typically just leave them in factored form. We don't want you to be multiplying them out. Part C here. So f of negative 4 is equal to f of negative 1 is also equal to f of 3/5, and they're all equal to 0. Well, if they're all equal to 0, aren't they zeros? Or, in other words, roots of the function? So, in other words, this is yet one more way that we can tell you the zeros or the roots of the function. And so, really, this is telling you the exact same information as part A and part B. And so, again, now it's saying f, so this time instead of saying y equals, I'm going to say f of x. And so, a times x plus 4, x plus 1, and 5x minus 3. Okay, now, did they give us any other information? Yes, a point on the curve is 3,98. So that is an x and a y that must work in the equation. So we're going to plug them in. 98 equals a times 3 plus 4, 3 plus 1, 5 times 3 minus 3. And again, I don't expect you to necessarily do it exactly like this. I would expect that you're going to do, well, 3 plus 4 is 7, and 3 plus 1 is 4, and 5 times 3 is 15, minus 3 is 12. Okay, so A is 98 over. Okay, now, yes, we can multiply 7 times 4 times 12, but we're trying to reduce the fraction anyway. And so, therefore, and by the way, you only get little calculators still. So I'd probably just leave it like this, 98 over 7 times 4 times 12, and then just start reducing where I can. So for example, I noticed that 98 is even. So 2 goes into it 49 times, and 2 goes into 4 twice. And 49 goes in, we've got 7 into itself once, and 7 into that 7 times. Let's see, this is not going to reduce anymore. So A is 7 over 2 times 12, so 7/24. And so if we replace the A with 7/24, we will be done. So f of x is 7/24 times x plus 4 times x plus 1 times 5x minus 3. By the way, does it matter what order the factors are in? X plus 4, x plus 1, and 5x minus 3. No, that really doesn't matter, the order. for those, because multiplication is commutative. Okay, well, you're not always going to get the same zeros, the same roots all the time. So let's try something else here. Write the equation for f of x, a fifth degree polynomial with roots. Okay, so they gave us the roots. And f of 5. Okay, so again, this is them giving us, it's another way of them giving us a point that's on the curve. So 5x, they're inputting a 5, gives us an output of negative 2400. Okay, and again, it's saying f of x, so let's go ahead and name it the way that they say. And multiplier, start with the a. 0 multiplicity 2. Well, if it's 0, isn't that just a GCF of x and multiplicity 2, so x squared? Negative 3, x plus 3, and plus n minus 2. So you got x minus 2 and x minus a negative 2, x plus 2. Now, x minus 2 and x plus 2, hopefully you recognize that that is x squared minus 4. And yes, you could, instead of doing x minus 2 and x plus 2, you could do x squared minus 4 as well. So let's take advantage of the x and the y that must work in the equation. And so we'll go ahead and do that. So negative 2400 equals a times, okay, now 5 squared and 5 plus 3 and 5 minus 2 and 5 plus 2. So a is negative 2400 over 25 times 8 times 3 times 7. Okay, well, let's see, 25 is definitely going in there. In fact, 25 times 4, if I change that 8 to a 4 times 2, so then the 4 and the 25 eliminate the zeros on the end, because 4 times 25 is 100. So now we're down to the negative 20, oh, and the 2 will go into the negative 24. Okay, so I'm getting a little busy right there, so let's, we've got negative 12 over 3 times 7, and let's see, 3 goes into both of those, and so the a is negative 4/7, and so if we substitute that in for the a, we will be done. So f of x is equal to, negative 4/7 times, I don't need parentheses yet. If there is a GCF, you want the GCF out in front with the a value. Negative 4/7 times x squared times x plus 3 times x minus 2 times x plus 2, or you could write it as x squared minus 4. Okay, last problem. Write the equation for the polynomial function that's graphed below. Okay. So another way that they can give you information is they can give you information graphically. So notice we've got zeros, negative 8, negative 2, 0, and 3. And if it's going through, you know it's odd multiplicity. And if it's bouncing, you know it's even multiplicity. Now, if it's going through, go with the lowest degree that goes through. So going through is 1, unless we get other information that indicates that we have to go to a higher degree. If it's bouncing, go with the lowest degree that will bounce. So even degrees, so second multiplicity 2 kind of thing. So as I'm writing this one, and it's f of x, so f of x multiplier a, just get used to writing the a. There is a there is a 0, and it's going through, so x to the first. Negative 2 is bouncing, so x plus 2 quantity squared. 3 is going through, so x minus 3, and negative 8 is going through, so x plus 8. Okay, so this would be x to the 5th, wouldn't it? And x to the 5th, odd degree, so low to high matches with that sort of thing, so that's good. There's always one less change of direction in a polynomial function or there's at most one less change of direction than the degree of the function. So what do I mean by change of direction? So you got the high point, that's 1. The relative minimum here at negative 2, that's 2. Kind of a high point there between negative 2 and 0, that's 3. And then between 0 and 3, there's a 4th one. So we know that this one has to be at least 5th degree. Could be higher than 5th degree, but at least 5th degree. So, okay, which is good. We've got 5th degree, and so that should be good. Now, there is another piece of information, so we do need to take advantage of it. Here's an x and a y that we plug in. And so, plugging those values in, we get 2592 equals a times the x of negative 6. Now, negative 6 plus 2 is negative 4. And it's being squared. Don't forget the squared. And negative 6 minus 3 is negative 9. And negative 6 plus 8 is 2. So a is 2592 over, okay, so we've got negative 6, negative 4, I'm going to write that separately, negative 4, negative 9, and 2. Now, let's just take care of the plus or minus of it here first. See how there's 4 negatives in the denominator, so we know it's going to be positive. Okay, and let's just take advantage of, okay, so here's a 2. The top number is obviously even. So, and your little calculator will do this sort of thing. So, 2592 divided by 2. Okay, so that's 1296. And there's some 4s there. So let's just try a 4. 1296 divided by 4. That went in evenly. So 1296 divided by 4 is 324. I'm going to switch colors here. It's still even. Let's try 4 again. Divide by 4. 4 went in evenly again. So 4 went in evenly 81 times. And we're going, oh, 81. Well, I see a 9 there. Okay, so 4 into 9 into 81. 9 times, and 9 over, remember we already got the fact that it's going to be positive. So 9 over 6. So 3 goes into both of those. 3 goes into 9. 3 times 3 goes into 6 twice. So A is 3/2. Okay, so replacing the A with 3/2, we have f of x equals 3/2 times x plus 2 quantity squared times x minus 3 times x plus